Okay, so this is the procedure that you go through when you want to do a two-sided test for a significance test. So this is when the alternative hypothesis is going to be not equal to the null hypothesis. So the p-value in a one-sided test is the area in one tail of a standard normal distribution. The tail is specified by the claim. I know it says the alternative hypothesis. So for this one, it's when we have our alternative hypothesis, the tail is specified by whether it is greater than or less than the claim that we have in the alternative hypothesis. In a two-sided test, the alternative hypothesis is p does not equal whatever that claimed value is. So in this case, the p-value is the probability of getting a sample proportion that's as far or farther than p naught in either direction than the observed value of the p-hat. Okay, so in this case, you have to find the area in both tails of a standard normal distribution to get the p-value. But our calculator will do that for you, so you don't necessarily really have to worry about that so much. So here's an example. We've got Benford's law again. We talked about this in earlier chapters. So Benford's law tells us that when there's no fraud, when somebody is submitting financial records, that about 30.1% of the numbers in the financial records will begin with a 1. So that's when there is no fraud. If the proportion of first digits that are 1 is significantly different from 0.301 in a random sample of records, AJL and Associates does a much more thorough investigation of the company. So they have a random sample of 300 expenses from some company's financial records, and 68 of them begin with a 1. So they need to figure out, do they need to investigate more? So our state is, we will test at the alpha equals 0.05 significance level. Since they didn't give us a significance level, we'll just use that. Our null hypothesis is the proportion of ones is going to be no different than if it was just a valid expense report. So p equals 0.301. The alternative hypothesis will be that it's just something different from that. So the p is not equal to 0.301. And p is the true proportion of all expenses that begin with a 1 for this company. So that's our state. Excuse me. For our plan, we will use a 1 proportion z-test if the conditions are met. The conditions are, it is random. We have a simple random sample of 300 expenses. Independent, so we're going to assume that there are more than 10 times 300, which is 3,000 expenses for this company. And then for our normal condition, we're going to do n p naught greater than or equal to 0, and n times 1 minus p naught greater than or equal to 10. So when we do that, we get 90.3 is greater than or equal to 10, and we get 207.9 is greater than or equal to 10. So therefore, the sampling distribution of p hats is approximately normal. Okay, so remember, when we're doing this, when we're checking for the normal condition, we want to make sure that we use the claim values when we check for a normal distribution as opposed to the p hat distribution, even though that tells us then that the sampling distribution of p hat would be normal. Okay, so then for our do, so when you plug all of this into your calculator and you do the same thing that we did before, so we would go to stat, and we would go over to test, and then 5 is our 1 prop z-test. So now in this case, our claimed value is 0.301. The number of expense reports that started with a 1, or expenses, was 68. Out of, how many was it? 300. And then again, in this case, we're testing that it's not equal to, okay? And then again, you could calculate or you could draw. The draw is pretty cool, so maybe I'll just do that. And so then when I do that, there's our curve. And I think because it's just so far out there, you just can't really tell that it's shaded very well. So the z-score is actually at negative 2.807-ish and at positive. So it's two-sided. Okay, so both of these little tails under the curve are shaded a little bit, but it's hard to tell because it's, you know, it's right here under the tail where there's not a ton of area. Okay, and then our p-value that we got from the calculator is 0.005. So when you write on your paper the what just happened? I skipped pages somehow. Oh my goodness. Here we go. So when you write on your paper, you want to make sure, because it's a two-sided test, you're going to say that z is positive and negative 2.807, and your p-value is 0.005. So that's just from the calculator. So our conclude, remember the conclude is always going to start off with p-value. So in this case, our p-value equals 0.005, and that is less than our alpha, which was 0.05, which means we are going to reject the null. And what that means is, in this case, there is convincing evidence that the true proportion of all expenses beginning with a 1 for this company is not 0.301. Okay, so it's different enough from 0.301 that it's statistically significant. Okay, so what does that mean in the sense of this company? It means that AJL is going to conduct a more thorough investigation about the expenses that this company has submitted. So, when you have something like this, a lot of times, so if you get to the idea that, okay, well, it's not equal to this, but I need to know a little more information, right? Sometimes the results of your significance test are going to leave you wondering, well, which direction does the truth really lie? Okay, is the proportion of ones bigger than 0.301 or is it smaller than 0.301? I just know it's different enough from 0.301 that it's significant, but I don't know which direction it is. And so then when that happens, then oftentimes we're asked to do a confidence interval to give us what plausible values for the situation would be, okay? So there's a link between the confidence intervals and two-sided tests. So we only do this for a two-sided test when our alternative hypothesis is that our p-value, or that our p does not equal whatever the claim is. Okay, so we don't do this for greater than or less than. We just do it when it's a two-sided, not equal alternative hypothesis. So the 95% confidence level is going to give an approximate range of proportions, claimed proportions as p-naughts, that would not be rejected by a two-sided test at the alpha equals 0.05 significance level. Okay, so 95% confidence level goes with alpha of 0.05. Okay, they're complements of one another. A 90% confidence level or confidence interval, you would use an alpha of 0.1. Okay, so continuing with our Benford's example, excuse me. So we want to find and interpret a confidence interval for the proportion of all expenses that begin with a 1. So we're going to state, plan, do, conclude for a confidence interval now. So for our state, we want to estimate the true proportion of all expenses that begin with a digit of 1 for this company at the 95% confidence level. Plan, what are we going to do to estimate that? We're going to use a 1 prop z interval now, as long as the conditions are met. And so we check our same conditions, but the difference here is, so we still have a simple random sample of 300 expenses. We're still going to assume that there's more than 3,000 expenses for the company, but the difference now is that instead of p naught, we're going to use p hat. So what we got from that sample of our 300 expenses. So when we do n p hat, that means we're doing 300 times the 68 out of 300, so 68. Okay, that's greater than or equal to 10, and then 300 minus 68 is 232. So that also is greater than or equal to 10. So therefore, the sampling distribution of p hats is approximately normal, and we can go ahead and we can use our calculator, okay? So we're going to, you don't have to write when you do the you don't have to write this stuff up here, okay? Don't write that because they don't want your calculator jargon. You can say the x value is 68, the number of expenses in this case we have is 300, and the confidence level that we're going to use is 95.95. And again, that's because our alpha level is 0.05. And so the interval that we get is 0.1793 to 0.2740. Okay, so that's the confidence. These are plausible values that would not get rejected. That would not be rejected by a two-sided test. Okay, so we are 95% confident that the interval from 0.1793 to 0.2740 captures the true proportion of all expenses that begin with the digit of 1 for this company. Okay, and then the other thing it asked is, did I not write this? This is from last year, yeah. So the other thing it asked was, does your interval from A lead to the same conclusion as your significance test? Explain. So again, because 0.301 is not in the interval, it's not a plausible value. So it's not plausible that this company really had a proportion of expenses who began with a digit of 1. That's 0.301. So therefore, again, yes, this company really needs to get investigated for fraud. So they got caught. I am going to stop this here so that the video is not longer than 15 minutes and make another one for the last little chunk. I'll be right back.